Are you sitting comfortably? Good. Then we'll begin.
For now, I will just start to share my screen with you. And in fact, I will share an application which is, let's see, ideal. So do you see the ideal screen? The programming environment.
Issues with a projector.
Okay. You should see now my computer screen. Do you see it?
Yes. We're good.
Okay. So I guess you already had the curiosity to see how these things work. In fact, you tested the license, so you are familiar with this opening windows in which you see this ideal programming environment. Now, if you look at the screen, you'll see three sections. One is actually the command line where I can type anything I want, yes? So I can say print hello, and oh, okay, and I will print it on the screen. You have here a section in which you see all the variables you create. For example, if I say x equal 1, you will see here x value 1, and the type of x is integer. So there are several types of data we'll discuss in detail later, but let's say y equals 1.5, you see? So this is y, float value is 1.5, and type is float. So are you familiar with integer and floating numbers? Just raise your hand if you know the difference. So the idea is that if we, for example, if I say print 2 times 2, yes? 4. Print 2 times 5 is 10, yes? So what are 2 and 5? These are integers. But if I say 5, I can even say 5 divided by 2 without even writing print. It will give me the weird answer, which is 2. Why? Because actually ideal is very strong type in one sense and very flexible in another. If I say 5 divided by 2.0, it gives me the answer that you would expect, 2.5. Why? Because if I say now x equals 5, and you see that I change the x here, and I say y equals 5, or 6 in this case, doesn't matter. I wanted to put actually 2. You see both x and y are integer type. And when I say x divided by y, and I get z equals x divided by y, I get z, which is another integer. So this is just the integer part of 5 divided by 2. So if I want z to be a real number, I have to say somehow to convert either x and y to a float number. So I can say float of x divided by y would give me an answer which is z, which is a float number. So you can play a little bit with this and understand that, so the difference between a float and an integer. And what I did here, actually, I used a function that is typecasting the integer to a float. So when I say print x, it's 5. But if I say print float of x, this is 5.0, which is no longer an integer, it's a float number. Now, this is important, and I wanted to start it with this because this is the a common mistake that everybody does. So you try to do a math operation, and you get weird answer if you don't pay attention to the type of data you are playing. So, of course, it's safe to use floats because you won't have this problem. But in most of the if you have this kind of operation, you want to take care. Make sure that the type is what you need to be. Now, what can we do with this? Of course, this is very simple. It's like a calculator. But I wanted to show you something more than something that IDL can do. For example, I can say x equals 1, 2, 3, 4, 5. When I say x equals 1, 2, 3, 4, 5 in this format, you see here that I have a type integer, but it's integer of 5. So in fact, x is a collection of 5 integers. If I print x, I get 1, 2, 3.5. So this is what is called an array of numbers. But what about y equals x squared? So, and here is where the powers ideal comes into play, because when I say y equals x squared, I obtain y, if you see here, also a collection of 5 integers, and when I say print y, is 1, 4, 9, 16, 25. So you see that IDL is making the operations in a different way than a calculator does. Like you can input an array of numbers and make an operation on the entire array, and it's very fast. If you are familiar with programming, another way to do it would be like for example, for in C, for I equals 0 to 4, do y of I equals x of I squared. You see? So this operation is doing exactly the same thing. Yes? And y equals the same thing. But this operation, it takes longer than the other one. So this is the thing. You don't have to write 4 statements if you can do in one operation. So y equals x squared. If I put to the cube and print y is 1, 8, 2, 27, 64, 125. So now these are operations on arrays. What can I do with this kind of array? I can immediately say something like this: plot x, y. And immediately you have a plot of your data. You see how simple it is? So you create a variable x, you write a function y of x, and you plot it. And it's very flexible. So everybody sees this window with the plot, yes? Please raise your hand. I want to get some feedback from you. Okay, good. So now I can do cool things here. I can say, okay, plot x and y. Or I can say directly plot x and x squared. Or, so this is a function. Or I can say now plot, which means overplot x and x cubed. And now you have x squared, you have x cubed. Or you want to see them in different colors to remember what is what, you can say this. So this is an application that allows you to change select some colors. So this is called xload CT. By the way, I'm recording myself here, so you will have the possibility to watch this presentation again when you have time, and go to through all these exercises. So I think I will provide you a link from which you will download this presentation later. So when I say X load CT, which means load the color table, you will be over the options to select some colors. For example, blue, white, green, red, or the one that I like. There are different color combinations. I like this rainbow 39. And when I double click on it, I say done. I can use colors now. The same way, without that, if I know what color table I want, I can use load CT directly without X and say 39. And I am loading the color table rainbow plus white. So now I can redo my exercise. I can say plot X and X square. And I will show you the windows here. By the way, maybe I can do this. Instead of having full screen, I can do this. And now you can see my command line and the plot window. Do you see them both? So do you see that plot window? So I can say overplot X and X cube color equals something. Now, what is a color table? A color table is a collection of colors that are indexed from 0 to 255. So if I say color 250, I know that is a red. So say this. Okay. Now I put it over in red. And I will overplot now X cube using another color. For example, I can use 100. Oh, it's not what I expected. Yeah, I think on the screen is not displayed in WebEx. Interesting. So this is supposed to be a blue, but for some reason WebEx changes the color. So do you see both of them red? Is that correct? Yeah. Okay. So can you try it on your laptop? Do you have IDL open? Yeah. Did anybody follow what I did?
Yeah.
So when you say load CT 39 and you use color 50, do you still see in red?
Yep. Yeah. Very dim red, yeah.
This is very weird. X load CT. Let me change another. This one. No. Okay. Okay, so I will see. I did not expect that, but I have a workaround. If we cannot use color for some reason, it might be something that I can change this. Instead of color, I can say line style. And line styles are different line styles. For example, I can say line style 1 or line style 3, and I can say also thickness of the line to be 1, 2, 3. Everything is to make it thicker. If I want it even thicker, I can do it like this. Yes. And so let's start again. If I go with our up, I can reuse previous commands. So I can say this line style equals 2, thick equals 2. Okay, and now I can overplot x equals, let's say, x cubed, line style 1, thickness 3, something like that. Now, maybe if you took, I understand that you all took physics classes, and I guess you are told that never do a graph without telling what you show on the graph. Is that correct?
Yep.
This plot doesn't tell us what we have here. So the correct way to do it is to start like this. I plot something, but I want to have x title equals, let's see, x, yes? And y title equals, let's see, f of x. Yes, maybe I should make it a little bit larger, and title equals my first ideal plot. It's not literally the first one. And now I just press enter. You see? Now we have a title, x. We have a f of x, an x title, an y title, and some data. Maybe I don't like this. Maybe you don't see it very well, so I can repeat this and I say character size equals 2. When I do this, I use bigger font. So everybody sees now what I have? So I say maybe x axis, something like this. So this is, I guess, very easy way to make plots and look at your data. Yes, of course there are sophisticated way to do it, but this is the most straightforward. From a command line, you can write, define your x, define your function of x, and after that you can plot it. Is clear so far?
Yes.
Okay. So this is what you can do at the command line. So let's now try to write our fourth program, because we don't want to keep everything on the command line, because you want to repeat and reuse the code. So let's start new program and make our first program and say a program starts with something called program. Yes, and you have to give a name of the program. So welcome to idea. Yes, and end. So now, in order to run it, I have to save it. You see, we have here a compilation, we have a run button, and if you press run, it will also try to compile it. But let's see what happens if I want to run this. When I want to run it, I will be asked first to save it. And where you save it is up to you. But I will use ideal comes with some ideal workspace default place where you can save your data. I think for now you can use this. Otherwise, you can browse and select your own place. So you see, automatically, based on the name of my program, Ideal created a name suggested a name. Welcome to ideal.pro. It's very important that the name of the program matches the name of the program inside. Otherwise, Ideal won't know how to run it. So it's important to have this to the same, but it's not case sensitive, at least on Windows computer. So I save it, and now let's say first command print hello. Okay, and now I compile it and I run it. And you see at the command line here, I have print hello. Do you see it? I run it again, I print again. Now, let's try to reproduce what we did so far. We load a color table, even if it doesn't work, and now we define X. Remember that we define X being what? 1, 2, 3, 4, and 5. But what if we want to have hundreds of X? So I say, I can do a very handy thing. I say, find gen. And I will say 100. And print X. Let's try. I can tell my program immediately. You see, X is immediately, if this find_gen is a very powerful function. If you hover your mouse over, you can see the syntax of this function. So the programming environment is very smart, and you can do this, or you say help on selected item, and you'll open the help about this function and how you can use it. Yes, so this is very handy. So this function says it generates a series of numbers starting from 0 and 100 of them, so they will end to number 99. So if you want to have number from 0 to 100, in fact, you have to type a series of 101 number, 0 to 100. So I don't want to print it. What I want actually to do is plot. And I say plot x and x squared. Or in fact, what I can do, I can go to my previous command that I already have somewhere in the command line. So what's here somewhere? Yeah? Maybe this one. And put the character size equals 2. And I think this is my command. So let's run my program. I guess we don't see it in order to run it, but I can do something like this show. Let's see if this one works. No. Okay. So now, this vShow is showing me the window, which is called ideal 0. So I say vShow, show me window 0. If I make another plot, I may use another window, but we'll get later there. So you see, I produce the plot, and now when you run it, it's automatically saved. You see, you are not asked to save it. So it's good because this is the default behavior. You can change it, but I advise you to save whatever you do, just not to forget to save it. So now we can add things to this plot. For example, I can say overplot x and x cubed plus x squared plus 1. So now you have this one. Or I can say plot x and x, and line style equals 2, or maybe let's make it 1. Where is x? Okay, so if no, I don't see it. Ah, it's here. Maybe I should say x plus 2000, and use this, another function. So this is x plus 2000. You don't see it very well, the variation of it, because adding just 100 to 2000, you don't see too much yet. But I can say like this, and I can obtain something else. Now, where are you? I lost sight of you. Anybody have any questions? Okay. Now, so this is my program, which is plotting something. But sometimes you don't want to write the function directly there. So let's try to do something more interesting. So before my program, I can define some functions. For example, I say function f. Okay, maybe not. Let's say my function, because if f is too generic, and I can put here an argument x and end. And now I can say y equals x squared plus x plus 1, for example, and after that I say return y. So this is the way you define a function. What is doing this function is taking x, is squaring x, adding x to it and 1, and returns the quadratic y. So instead of saying this here, I can say, okay, let's change my program, delete these lines, and instead of putting x squared here, I say my function of x. I'm compiling my program, and you see the minute I compile it, my function is colored, which means that I will understand what it is. And now I can run it. So this is very handy, because now if I want to change my function, I don't have to change the main code. I can say, okay, maybe I don't like this function. I want to add 100 to it or 1000 to it, and try to start from here and go there. So this is how in the same program I define my function and I can use it. Yes. What is cool about it is that you can work with both a program and a command line. For example, I'm at this point, I will know whatever I did so far. So if I say, but okay, it doesn't know what x is. So x is still outside of the command line. X is just number from 1 to 5. So what I can do, I can say plot x and x squared over my windows. You don't see it here. So maybe I can say plot 50 x squared plus 6000. And you see I overplot something on my graph using other source of x and y. So what I wanted to tell you is that whatever I define inside my program is not seen outside my ideal. In fact, I can reset my ideal session and all the local variable will disappear, and I run my program again, and you see there is nothing outside. So ideal doesn't know anything about X and Y, whatever is defined in the program. Everything is used internally by my program. But I can still do things from outside if I want to. But let's try to do it this way. So now I want from you, maybe this is too simple from you, so I want a challenge. So can you ask me to do something? Maybe see if I can do it. Yes.
Is it possible to graph anything with a 3 axes?
A 3D plot?
Yes.
Yes, it is possible to do 3D plot. In fact, but we have to cover many things. So I can go this. I can show you. You can find examples. Where is ideal? For example, there is a function for surface. Okay, by the way, if you have Windows 10, as I have, it's better not to use it with ideal. So ideal, Google is better. So if I go to, oh, are you still on? Yes. Hello? Okay. Because I went to, so let's try something here. So surface. Sometimes you can do, so you are looking for something like this, yeah?
We can't actually see anything. It's just...
You don't see? Okay.
Yeah, so right now we see something like gray screen.
I don't know why. Ah, I know why. Okay. Because I'm not sharing anything else but idea. Okay. So let me fix that. Where is my WebEx? Here.
So go up, return, and start sharing screen.
Stop sharing screen, and now share my screen.
Yep.
So now you see my screen, yes?
Yes.
Okay. So now, what you are looking for, I think you want to do something like this, yes? To do a 3D plot. And what is cool about this help of idea, that there are many examples which are embedded into the help. And in fact, you can go here, copy, and go to command line and just paste whatever you read there. And the last command, you just hit enter, and you have the result. Did you follow me? So basically, what I did, I went to the ideal help, I looked for surface, how to do a surface plot, and I found an example saying create a surface, and they say, okay, you can do this surface, yes? But you can do, so this is an example, and now you know how to use this function, which is called simply shade surface procedure, and it tells you what arguments to give it to it, and it shows you the output of this, yes? So for example, I can say copy this command line and say paste. And now you have this one. Or we can go to our program, yes, and just copy it from the help file. I think we had two commands here. Yeah, and I will do something like this and show you step by step what this program is. And I think this is also handy thing. If you go on the right here, on the left, and double click a line, you use something that is called a breakpoint, yes? So let's put it here. And run my program up to this point. Do you see both windows, Gregory? Do you see it? Yeah, okay. So now, up to this point of the program, I did what I wrote myself. But from this point on, if I go step by step, I can go here, step, over, one line. Now I define my function v, and now the next instruction will replace my plot with this plot. And now I have this plot. I go one more line, and now I overplot the grid on the mesh on the surface, and this shows. How do I? Now I lost the sight of view of you. So, Gregory, I see you. I would like to see the class.
You can work with tech participants.
Yeah.
That's up in the screen, I think.
I don't see participant, yes? Okay. Trying to make this window larger. Hey class, is this what you wanted to see? Okay. What else? Maybe you want to see the powers of ideas. I try something for you. Object view. And try something else than this kind of plot. So, because we are close to ending this session, so I wanted to show you something else. For example, in the end of my program, I would add what I can type that directly at the command line, but I want to share with you this program, so I will put this. So this is creating something more sophisticated, a plot, which is something called object. So if I run, you have a Windows like this, and you can have an object that you can manipulate and look at it, a 3D object. And this is done only by these two examples, these two lines. So maybe I find something more sophisticated. Maybe something like this. and you have something like. Now, this is already, it's not that hard, but the idea is just I wanted to show you the power of Ideal. So basically, this is Ideal is a powerful application for viewing your data, and it's very important to see it in certain ways. So this is, I would say, the most sophisticated way when you have a 3D object, you create it, you put it in a virtual space, and you can manipulate it, color, put light on that. So you can go from this, which this one is a static plot. You cannot change anything to it once you do it, or you can use something that you can interactively change, like that, objects, which they live in their own space, virtual space, which is a window like this. And to obtain this, you don't have to write too much code. So this is the powerful. For example, the last object, we have this thing. I create a model, I add some lights, and I display my model. Of course, you have to learn something, and I don't want, it's only up to you if you want to go in these details, but many of the programs that I created and we are going to use this summer for our research, actually, they are this kind of application in which you manipulate objects and you look at the results. Yes. And but next time I will get into this, and I will, in order to do that, you will have to install some modules beside the one that came with Ideal, and I will send you links how to install it. Please follow the link, install the required modules, and next week we can test some of the programs that we are going to use this summer. And whether or not you want to get into programming is up to you. So I will encourage you to play, try to go to examples and think about, okay, whatever you think you may want to see, you just try to go to index in the Ideal help and look for things and look for examples and see how they work. And very easy. You just copy, paste them in a program, create your program, save it if you like it, and play it again all over and over. Any questions? So I would end my presentation now.